Here we go. 1.09, interpret trig models. We have one goal, but there is a lot in this goal, so let's break it down. Interpret key features of a trig function. So key features meaning all the things we've learned about, period, frequency, midline amplitude, all that good stuff. From a graph, a table, and an equation. We're really going to focus on tables today. You will see an equation as well. Not so much graphs. Yeah, I don't, maybe one graph at the end. But the main focus today is really with real world context it represents. So we're dealing with real world situations. Let's get into it. Sinusoidal functions can also be interpreted when they're represented in a table. This is our first time seeing them in a table. You've seen them in graphs and functions, but now a table. For example, this table you see gives the amount of precipitation. There it is, inches of precipitation in a rainforest. So we're talking about inches of rain in a rainforest. Of course, that would not be Southern California. We get nowhere near 200 or 300 inches of rain per year. And this table shows us those inches of precipitation over the course of 18 years. Okay. There's actually 19 years because there's a year zero there. And they're saying year zero is 1980, which isn't going to help us solve this, but it just helps us visualize when and where this was happening. So we have inches of precipitation, and then our column to the left of that is the year. Okay, now they're looking first, they're asking for the max amount of rainfall in 1 year. Max. Well, usually that's the biggest value, isn't it? And usually time is the x-axis, and whatever the other element is the y-axis, and that's absolutely true. You'll see 320 is the biggest value in this table, 320 inches. The min value, what's the min? That would be the smallest number. Smallest number I see is 80 inches. And the amplitude, okay, amplitude, we have our amplitude formula. Max minus min over 2. We already found those values, didn't we? 320 minus 80. You could do this on your calculator. Quickly in my mind, the way I would do it is get this to 300. So 320 minus 20 is 300, and then minus another 60 gets us to 240. So we have 240 over 2. 2 goes into 2 once, 4 twice, and 0, 0 times. So the amplitude is 20. And finally, period. Okay? And period is not only where the same number repeats, but where the pattern in the numbers ends. So the first thing you should do is absolutely look for the first number that repeats. So we're going to start with 320, and we're going to find another 320. So we go down, 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 down. There it is. Okay. Now, the question is, does this repeat after that? Let's see. Um, this goes 320, 304, 260, 320, 304, 260, 200, 140, 200, 140. Yeah, it looks like we've identified the period correctly. So it's going to be this entire blue shaded region, right? So one period goes from 320 to 320. And of course, there's overlap, right? Because what kind of sinusoidal graph or sinusoidal function is this? Well, we're starting at the max and we're going to the max. So that's going to be y-intercept at the max. That's a positive cosine function. And of course, we need to start where we end because the next period picks up where we left off. So that 320 is a shared number, right? That would be right here, signifying the max. but also the point of the new period beginning, right? So, what is the period? We've identified it, and I've drawn and made a mess all over this table. So let's clean it up. The period is the amount of time it takes to go from 320 to 320. Well, if you look on the left, how much time has passed? 12 years. Okay, but period we just write as a number. So P is 12. Another table, another real life situation. A 24-hour fast food restaurant has observed a sinusoidal pattern for the number of cups of coffee sold. So once again, we have time on the left. This time it's in hours, and then cups of coffee sold each hour. So 40 cups at 6 a.m., 70 cups at 9 a.m., and so on. The table represents the data gathered over a 1 day period. Identify these three elements: frequency, midline, and amplitude. Okay, frequency, let's start there. What is frequency? Well, that's the reciprocal of the period, right? So if we can find the period, we can find the frequency. So let's look. We start with 40. Where do we see 40 again? Right here. And this is what I was talking about before when I said the period is not only where the same number repeats, because here we see 40 and 40 again. So the number is repeated, but the pattern didn't end there, did it? Because is there a 10 in this blue region? Clearly not, right? So we don't have all of the numbers in the pattern. We need to go all the way till we see 40 again. And this should look familiar. This should look like a cosine wave. So you go from mid to mid. And remember, when you go mid to mid, you skip the middle mid, which would be this guy right there. So we've properly identified the period, at least the part of the graph where it is, but what is it actually? Well, we need to look at the time. 6 a.m. to 6 p.m., that's going to be 12 hours. But we need the reciprocal. 12 is the same as 12 over 1. Flip that around, we get 1/12. Midline. Midline, midline. Well, I already kind of pointed out that it's a positive sign function, so we have mid, mid, mid. We know that it's 40. But let's actually use the formula. What is that? That's max, which is 70, plus min 10 over 2, 80 over 2, which gives you the 40 we had. Now, amplitude is a distance from the mid to the max. And we know mid is 40, and we know max is 70. So you could do 70 minus 40 to find out that it's 30. Or you could use your amplitude formula, 70 minus max minus min over 2. So you get 60 halves 30. And now it's time for some real life problems, but now we're looking at a Ferris wheel. So a little more interesting, and I'm sure we've all been on a Ferris wheel at some point in time, right? So let's see how we can conceptualize this and answer the questions that are asked. Sam is riding a Ferris wheel at the county fair. Cool. The function we see here represents the height of the seat Sam is in on the Ferris wheel in meters at any time x. Remember, in sinusoidal functions, x is the variable of time. So if you plug in a certain value for x, you can find out, oh, Sam was here. Then he was here at that time. Then he was here at that time, or here at that time, depending on the x value you put in. So really, they're just saying we're working with a sinusoidal function, and Sam is going for a ride on the Ferris wheel. Okay? and the unit of measure is seconds. Identify the diameter of the Ferris wheel. Well, let's refresh on what diameter is. Diameter is the distance straight across a circle from one end to the next, right here, right? Well, we haven't really learned how to measure that too much, but we've really focused on measuring from the mid to the max, right? Which is the amplitude. And then we could just multiply that times 2, right? So what do you think it is? Remember, the negative in front does not attach to the amplitude. So one way you might think about it is it's the absolute value of whatever you see. Because amplitude is a distance, it must be positive. Well, if the amplitude, the distance from here to here is 16, then we just multiply that times 2 to get your diameter. So diameter, we'll just put D for diameter equals 32. Did they tell us what meters? Okay. Now, how many meters off the ground was Sam at the start of the ride? Hmm. Well, did he pull a King Kong and climb the Ferris wheel and get on at the top? I really hope not. He probably got on right here, right? So what are we doing? We're showing where the ground is. Let me draw that flat line. And then we know the amplitude is the distance from mid to max, which is also the distance from mid to min. So this is 16, right? That's the amplitude. But what else do we know? Well, we need to look back at our function, don't we? What is that 18? That, my friends, is the midline. So if the midline is right here, and we're told the midline is 18, that means the distance from here to the ground is 18 meters, right? So what's the difference? How far is it from there to there? Well, that's a simple subtraction problem. 18 minus 16 gives us 2 meters. That's where Sam was when he first got on the ride. Now, same scenario, different question. How long does it take for the Ferris wheel to make one complete revolution? Starting at the bottom, going all the way around. How long will that take? We call that a period, right? So how do we find P? Well, there's a formula, right? 2 pi over B, and look at that. We are given B in the function. So all we need to do is plug that in and work it out. Pi over 30. Now we have a complex fraction. You've done this many times this unit. You keep, you change, you flip. Pi's cancel out. 2 times 30 is 60, and we're talking about seconds. The real life problems, they can be fun, they can be interesting. I know they can be also frustrating in the beginning, but stick with it. Study, take your time, and they'll become easier. Just as all math does, the more you practice, the better you get. And here is our exit ticket. The function you see models the number of Nike shoes sold each month over the course of a year at the Nike store downtown. For this function, x is 0, and that represents January. X equals 1 represents February, and so on. So you need to know your months. If you don't know your months, look at your phone, look at a calendar. Give this your best shot. This is a great test of understanding to quiz yourself on these before I work it out with you. And here we go. Question number one. In what month or months were the fewest number of Nikes sold? So we need to know the min, right? Okay, well, what did they say? They said x equals 0 represents January. So we can say January is at the x value of 0 right there, right? Then if this is 0, then February is 1, right? January, February, March, April, May, June. But so to June is 6, but we started at 0, right? That first one counted as 0. So we get to 6, we're going to July. Okay? So we go from January to July. That's 6. And then July to 12. What would that be? July, August, September, October, November, December, and then now I'm getting confused with the months. So we don't need to count that all out. Let's just go back to the question at hand. In what month or months were the fewest sold? We do need to find the period. Okay? So you've used that period formula. 2 pi over b. Once again, keep change flip, cross out your pi's, multiply across. Period is 12. Okay? And we know it's a positive cosine function, so that's how we know. We start at the max, and I'm going to graph what we find as we go. So that means we start at the max, we're not sure where it is, but we know we're in the middle will be the min, right? So if the period is 12, we know at 6 we'll be at the min. So in what month? July. That's the only thing we really know so far is where that min is. Then, what's the greatest number of Nikes sold in a month? That means we need to find the max. So to find the max, we need to first find the midline. There's the midline, 80, right? They tell us right there. Then where's the max? Well, you take your amplitude, add it to your midline. Because this is your amplitude, mid to max, right? That's a distance of 75. So 155, we now know the max, and we know we're going max to max, and we know these points will be at the mids, based on the behavior of a positive cosine function. And in how many months over the course of the year were 80 Nikes sold? Well, we just found that out. Where our graph hits the midline, 2 different months. They didn't ask which specific months, just how many. So that's all we need to do. We are done with 1.09, my friends. Complete the lesson that we'll ask to study. Watch this again if you need to, and take your first attempt of the 1.09 quiz today.